We are Group 21 and these are my team member and our roles as stated. The purpose of this project is to design and develop a movie recommendation system that incorporates sentiment analysis of the movie review. But before that, we have to crawl the necessary data to build our system. So, how do we scrape our data? Due to the limited number of API requests can be made per day, we had to use Scrapy to collect the movie data from the IMDb website by ourselves. It's an open source web scraping library written in Python that can be used to extract useful text information related to the movie through the CSS selector. We will produce two final outputs stored as JSON file, one mainly for display, querying, and indexing purposes, while the other one is used for sentiment analysis and model training. Here are the statistics of some of the crawl data. Note that only the words for movie description and review are calculated, as these two attributes are more relevant to the indexing, querying, and classification processes.
This is the overview of our system. We are using React as a front end, Express as a back end, and Solr as the database. For indexing in Solr, we first create a Solr call to store our data. Then we customize stop words, add new field types that specifies tokenizers and filters for querying and indexing. Then we ensure that the index fields are copied to the default search field, and we finally import the data into Solr. Now we can query Solr. We would like to show some enhancements made. The normal query returns a JSON body containing all the stored fields in the mesh documents, and it's sorted by a relevance score. Next, for fuzzy search, we can misspell Tokyo Drift with missing suffix, and when queried normally, no results are found. However, using fuzzy search and one character edit distance, we are returned with many results, of which the first being the same movie from the previous slide. Lastly, the more like this query, we can pass the ID of the Tokyo Drift movie as an argument to the query, and the top results are the movies from the same franchise, which is relevant and satisfies our use case.
For the classification, we will do the sentiment analysis for subjectivity and polarity detection. So the overall process of the classification you can see here. First one is the data processing, which we will do firstly is the data cleaning, which we expand the contraction, remove punctuation, and convert everything into lowercase, and also we will remove the stop words. Next is the annotating, which is we will use the NLTK and text block to obtain the two labels of the subjectivity and polarity, and also we will do the manual annotation for the test set. For the feature extraction, we use the count vectorizer TF-IDF and ngrams, which consists of the unigrams and unigrams plus bigrams. And for the classification models, we use the logistic regression, naive Bayes, random forest, and support vector machine. For the enhancement and innovation, firstly we use the ensemble model, which is we use the top 3 model, that is the logistic regression, naive Bayes, and support vector machine with hard 14. And the second one is grid search on the base model, which is hyperparameter tuning for C and sulfur. And as seen in the table, the best result comes from the tuned logistic regression and not the ensemble model, because the ensemble model increases the model complexity. Next is the demo time. That's all from our group. Thank you for watching.